Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll use implicit differentiation to find dy over dx for the given equation y times square root x plus x times square root y equals 15. We have to use implicit differentiation for this equation because we cannot isolate y in this equation. This is a very important concept we need to understand and memorize. The first step is to change the square roots into rational exponents 1 over 2. We have to find dy over dx for this equation. So we have to find the derivative of the three terms in this equation with respect to x. Let's start with the first term, y times x to the power half. This term is made up of two functions, y and x to the power half, and they are being multiplied, so we have to use product rule for this term. As per the product rule, we start with the derivative of the first function y. The derivative of y with respect to x is dy over dx times the second function x to the power half plus the first function y times the derivative of the second function x to the power half. We can find the derivative of x to the power half with respect to x using the power rule. As per the power rule, we move the exponent half to the front of the term and subtract 1 from half. We are done with the derivative of the first term. Now we can find the derivative of the second term, x times y to the power half. This term is made up of two functions, x and y to the power half, and they are being multiplied. So we have to use product rule to find the derivative of this term. As per the product rule, we start with the derivative of the first function x. The derivative of x with respect to x is 1 times the second function y to the power half plus the first function x times the derivative of the second function y to the power half. We have to find the derivative with respect to x, so we have to use chain rule. In the term y to the power half, the inner function is y, the outer function is exponent 1 over 2. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent 1 over 2 to the front of the term and subtract 1 from 1 over 2 in the exponent times the derivative of the inner function y. The derivative of y with respect to x is dy over dx. This is the derivative of the second term. 15 is a constant, so its derivative is equal to 0. Now we can simplify this step. We can change the rational exponent 1 over 2 to square root. Half minus 1 is negative half. 1 times y to the power half is y to the power half, and we can write the exponent half as square root. Half minus 1 is negative half. We can change the exponent on x to positive 1 over 2 by moving it to the denominator with 2. We can do the same for y to the power negative half. Next, we should change the rational exponents 1 over 2 to square root. we have to find the value of dy over dx. So we have to isolate dy over dx in this equation. We can simplify this equation by getting rid of the denominators 2 square root x and 2 square root y in this equation. We can do that by multiplying each term in this equation by the lowest common denominator, and that is 2 square root x square root y. This is the common denominator. So we should multiply each term in this equation by 2 square root x square root y. I get 0 times 2 square root x square root y is equal to 0. Now we can simplify the terms. In the first term, square root x times square root x is equal to x. In the second term, 2 and square root x cancel each other out. We are left with y square root y. In the third term, square root y times square root y is equal to y. And in the fourth term, 2's and square root y's cancel each other out. Next, we can keep the dy over dx terms on the left side of this equation and move y square root y and 2y square root x to the right side of the equation. That will make these terms negative. Next, we should factor out dy over dx from both terms on the left side. Next, we should divide both sides by 2x square root y plus x square root x to isolate dy over dx on the left side of the equation. On the right side, we can do common factoring. We can factor out negative y from the numerator terms and x from the denominator terms. This is the value of dy over dx. We cannot simplify this expression, So this should be the final answer. So these are the steps you have to keep in mind to find dy over dx for this equation. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.